Hello everyone, welcome back to another update on Kwyll. Firstly, my apologies for not keeping up with what I promised to do last time, which was more regular updates on a weekly basis. There's been a number of reasons, but no real excuse. I did go on holiday for a while, so that took some time out. Most of my time has been spent on Kwyll, most of my Kwyll time at least has been spent deep in optimizations. So each of these changes to the core code for the Spectrum side take a significant amount of time and effort, so I don't want to stop mid-flow and produce a video, especially when most of what I'm showing wouldn't be particularly interesting. So there's been a bit of a delay again, but we've got a few things to show now, and I'm getting closer to the end goal, which is a beta release. So I'm still aiming for a beta release. For anyone following on the Discord will know that my goal is to get a beta release out in time for Crash Live 2025 here in the UK, which is the weekend of the 16th of November, 15th, 16th of November. So I'm still hoping to get a beta release, a version of Kwyll in a state that can be beta released for then, so that I can show it at Crash when I'm there. I think I'm pretty much still online for that. I was hoping to be able to squeeze more memory out, but that's looking less and less likely now. But I'm still aiming for maybe 15k, between 12 and 15k. I was hoping for a little bit more than 15k, but 12 to 15 is looking more likely as things stand at the moment, but still moving in a good direction. And I've been making some changes that will optimize the data that you export for the game as well, so you can make more use of that 15k. So I'll get into some of those changes now. So I've got a list as usual of changes, and I'll demonstrate the key ones that can be shown in the Kwyll editor, and just go over a little bit about the sort of background stuff a little bit more as I go. So if we switch to Kwyll, this is the latest version. A couple of things have changed or been added since the last time. A few nodes, so I'll go through the nodes first because it's the easiest thing to go through. If I go to the primary game logic window, so we can just look at some nodes. There's a let me just check. There's changes to the object flags. I can find it. Set object flags. So if you remember in the last video, or a video maybe 2 videos ago, I changed the way that the system detects intersections between objects. Before it was a simple, there's a collide background flag here, there's a parallel collide with objects background, so it would basically check for intersections between all objects. That proved to be problematic in terms of performance excuse me, because checking all the objects against all the other objects, especially when you got things like bullets and bombs and stuff flying around, was quite processor intensive. So and in many cases, I've already explained this, but I'll just go over it very quickly. In many cases you don't need to be checking for collisions between objects. You don't need to check for collisions between 2 enemies, for example. They don't care in most cases. So I changed to a system where you have objects placed on one of 8 layers, and they can check for collisions against or any number of 8 layers actually, so you can have them exist on multiple layers, and checks against multiple layers. So using those two, that combination of where the object exists and what objects it is interested in, you're able to fine-tune control over which objects intersect and which don't. So for things like enemies, you can say don't bother checking the enemies against other enemies, for example. But you had no way until now to actually modify this from the logic, which was key. So I've added this now, so you can choose which layers you want to switch to from within the logic node, or the usual flag over here which just says don't change what they're currently set to, and the same for checks layers. So for example, the equivalent in this new approach of turning off the collide with other objects flag is simply to switch it to 0 layer, because if you have it on no layers, then it won't collide with it, or it won't intersect with any other objects. So that's the easy way to turn off collision detection. But you can also move it to other things, so it doesn't impact or it doesn't detect intersections with other objects. That's the first change. I'll just go through the list here and stick to logic changes while we're in this mode. So another thing was a new node, which is, if I can, modulo. So we always had clamp and wrap, so that I'll just show you the wrap one because that's related. So the wrap will take an input value and wrap it round within the limits of 0 and the max value specified. So if you set the maximum to 5, it'll go 0, 1, 2, 3, 4, 0, 1, 2, 3, 4 and wrap round constantly. The modulo allows you to take a number and basically return the remainder of dividing it by the value specified. So if, for example, you input 5 and divide by, or you set the divisor to 2, it will return 1, because 5 divided by 2 is 2, remainder 1. This is actually very useful for various logic things. I won't go into the use cases, but that they are important. So that's just another new node, which gives a little bit more capabilities. Another change in the nodes is the and or nodes, which, if you remember from the last video, have this logical flag now. But and the other thing I hadn't introduced until now was, prior to this, the A and the B values had to be input from external sources. So with this new change, you can actually bring in an external source for the A and then manually enter a value, so you don't have to create before. If you wanted to AND it with a particular value, you'd have to create a node like that. This just makes it a little bit easier and puts it in line. So small but useful quality of life changes. Let me just check if there's any other node related ones. I think that's all. I'll come back to it if I need to. There is one that touches on nodes, but it's a bigger issue, so I'll come back to that in a minute. So that's basically some of the changes that have been happening in the logic. The logic is stabilizing now, so there's been fewer changes as I've completed more and more features in there, and it's proving itself in testing to be capable enough. So moving on to the next feature. So some of you may remember from the previous video I highlighted some projects that some of the guys, the people in on the Discord are creating using Kwyll, using the early access Patreon users. One of them was a remake of one of the levels in Manic Miner, which tested a whole bunch of features and highlighted a whole bunch of performance issues. One of which was the animated tiles, so for things like the conveyor belt and so on. So there was a way to do animated tiles using logic, because we have the modify tiles node, which allows you to change tiles in the live tile map. So there was a way of doing it, but obviously that's not particularly efficient, especially if you're changing a lot of tiles and you're changing them every frame. So it proved to be a performance bottleneck. So I took the opportunity to look into, alternatives for doing animated tiles, because animated tiles seem to be, from discussions on the Discord, a popular feature that most games, or many games, would want. So if I just quickly load a sample that I've got, I can demonstrate this. So the way it works is you create your tiles as you normally would. So this is in the screens editor, where you can place tiles around the window. So we've got these 4 tiles here that I've created that are a rudimentary spinning wheel thing through 4 frames. And if you edit the properties of the lead tile there, you can see we've got this new feature in here, which is the animation. If you specify anything other than 0 in the frame count, then the system will play this one and the following 4, in this case, tiles in sequence as animated tiles at the rate specified here. So this is, as with all animation, this is a number of frame skips. So with 5, if the game's running at 50 frames per second, you'll be running at a tenth of a second per frame, so 10 seconds per frame, 10 frames per second. So that's just basically a very simple way to animate a tile without getting into too much complexity. You draw your tiles as you normally would, and you just choose one as the start point and say how many of the following frames you want to animate. And if we look at any one of these, they don't have any animation, so you can still paint with those, you can still draw them as static tiles, but they won't animate, even though they are part of an animation, only if you draw with this one. So you can see this works. I've pasted some here in the screen, so you may or may not know that you can place tiles in a tile map in a screen as well as in the game itself. So just to show this one, I've pasted 3 tiles there, and then in the rooms as well. So I've got these 4 tiles, and if I select the room, I've just got one tile in the middle of this room, which is an animated tile. Now the way this works on the, well, in general in Kwyll, but on the Spectrum in particular, I didn't want to impose too much of a performance hit, and the system needs to keep track of which tiles overall on the whole screen at any one time are animated and which aren't. So scanning the whole window and keeping a list of all of the tiles that are animated would be every frame would be a performance hit. So instead, the system keeps track of a limited number of tiles that are animated, and it only updates that list when something changes the tile map. So for example, if in Logic you do a paste brush or a modified tiles, or you change room, it will update its list of tiles in that current scenario that are animated. And to control the amount of memory lost to this, you have to manually choose in advance how many tiles as a maximum you're going to have animated at any one time. This is done in the project settings, as with all things. So if we look here, we've got this new entry, max animated tiles, which is currently set to 20. So it'll keep track of up to 20 animated tiles. If you paste animated tiles either into the room or into the screen that are beyond that limit, they will just be pasted as static tiles. They won't animate, but they'll still show. And I can demonstrate this. So in here I've got, as I say, in the room I've got one tile I've pasted, and if we look at the brushes, I've got a single brush with 9 additional animated tiles in it, and I've got some logic in the room which jumps through a few steps. This is my standard test file, so you push the space bar and it does this action, and then this action, and then this action on each subsequent press. In the first one, it pastes 2 brushes, 2 copies of that brush, and then sets the variable so that on the next way through it does the next action. This one uses modified tiles to paste an animated tile, and then the third step is to use modified tiles to paste a non-animated tile. Now, pasting 2 brushes at 9 each, plus the 1 in the room is 19, plus the 3 on the screen, you'll realise that we overrun the maximum amount. So you can see the effect when I run it in preview. Initially, you've just got the 3 in the screen and the 1 in the room, and everything's fine. As soon as you paste those 2 brushes, you've got 18, 19, 20. These 2, because it scans top to bottom, left to right, these 2 are no longer animated. They can't be tracked. Everything else will go as normal. Then if I hit space again, it pastes an additional single animated tile, which knocks this one out of the list, so these 3 can't animate anymore, but these all can. And then finally I paste over that one with a non-animated tile, and the system updates again, and this one becomes within the limits again. So you can tweak the number of animated tiles that it will track. So there's a small memory overhead as you make it bigger, so try and keep it at a reasonable size, the right size for your game through experimentation. But this will just prevents it getting out of hand. And that all works on the simulator, on the emulator, on the export as well. So I won't show that. So that's animated tiles. We've done those. Preview speed control. So you can see here, you may have already noticed I've got this speed control. This was put in because I realised when I was doing some game creation myself, or working on helping out some of the Patreon users with their games, that quite often when a game gets beyond a certain level of complexity, it struggles to reach the 50 frames a second. In fact, it very rarely reaches 50 frames a second on the Spectrum, just because of the overhead of managing the sprites and the logic and everything. So while the simulator is a useful tool for checking that logic works and so on, it was not so useful for actually tweaking how, for example, your jumps and your controls will work, because they would feel a certain way in the simulator at 50 frames a second and feel very different on the Spectrum at a slower speed. So now you can just manually tweak how many frames per second, and it throttles the simulator. So if I'll just play this one and bring these up. If I throttle this down, you can see everything starts to slow down. And it's very useful for, as I say, for things like managing your controller. So if you've got a platformer and you want to know how it's going to feel with the jump speeds and the playability, you can just tweak this down to something that approximates what it looks like it's running at on the Spectrum when you try it out on your emulator or real hardware. That's that one. The next one on my list I'll come back to because it's a big one. Timeout compression. So if I open a file with something more interesting in and go to our rooms, so the tile map exports as a series of layers. So it exports the tiles, the attributes, and the collision information as 3 separate layers, and it's always tried to sort of lightly optimize the the export to avoid using too much memory. So the very naive way of doing this would be just to export a byte for every cell in the window, which would be ridiculous because most of them are empty. So it used to do it in spans. So it would do a span for this row, saying it was starting at 0, and it's 32 bytes long, and it lists all 32, and so on. Then you'd have a span here starting at 0, and it's 1 byte, and then a span at cell 31, column 31, and 1 long, and that's how it would work. And that was okay, but there's a lot of things you can do to improve on that. So I decided to take some time. I didn't want to go too far where you spend more time decompressing on the Spectrum, but a few simple additions can make a big difference. So I'm using now a method which is kind of like run length encoding, which is a very, very basic, simple compression mechanism. So it will spot repeated sequences of the same character. So for example, this one here is all the same character across the top, I think. Let's pretend for the sake of argument that it is. This would export as 1 there for the corner, and then 1 byte and a count of 29, and then the cell. So this would go down from 29 bytes to 3, if you see what I mean. So then when it comes to decompressing, it would spot the special code here and say, the next tile is to be repeated 29 times, and it just repeats it. So this allows more common tile map designs to be exported at much lower memory use. So frees you up to do more with the tile maps without worrying necessarily about having to jump into doing complex brushes and so on to save memory too early. You can get away with a lot more in the tile map now. This made a big difference. I think for things like this and some of the other games, it was reducing the tile map size by anything up to 70%. So big saving on the export. Let's look on to the next, see what the next thing is. In relation to that, so one of the things it was always doing was it would export every room. So there's 4 rooms here. It would export every room, including all of the objects, the tile maps, brushes, and so on, and markers. And then in the map, you've got where the rooms are used. Now, if any one of those rooms was not used on the map, it would still get exported and still count against your memory use. And it turns out in watching what some of the Patreon users are using it for, that it's quite common to use a room as a scratch pad, if you like, or a working area to build your brushes and try out some ideas, and that would still count against your memory footprint when you do an export. So now a very simple change: if the room isn't used in the map, it doesn't get exported. And this is because there's no way of actually changing the map even through logic. So the map is a representation of exactly which rooms are going to be used. So this just frees you up to have a room in here which you could have as a scratch pad or something, and you can draw outside of the area. You can draw all over here and build up your brushes and edit your brushes and try out different ideas for design without worrying about having to go back and delete it later before you do the export. So that's that one. Another one that's very difficult to explain, but I'll try and describe it. So one of the principles of Kwyll during development is that you try to do as much as you can in Kwyll and in the simulator, and that means I need to do less checking, less validation on the Spectrum side, because every time you have to check for valid entries, valid arguments, valid values, valid parameters to logic nodes and so on, is a cost in performance and memory, because it introduces new code. So the idea is the Spectrum will just presume everything is okay, and it will just run the code that it gets blindly as fast as it can. Whereas on the simulator in Kwyll, it will do a lot more checking and report back in the simulator if something is out of range, something's a problem, and you fix it in Kwyll before you export. That's the basic underlying principle. And one of the changes I've added is, if we remember, there's a repeat and a while loop which were introduced a little while back. Now the repeat one's not so much of a problem because you're bracketing the amount of times it will repeat. You start at a certain value until it reaches a certain value in steps, and that's fine, so that's okay. Put that one to one side. But the while loop is problematic, or can be problematic, because this will execute whatever's connected to the body as continually until the input on the condition port is false or 0. So it's very easy, I mean painfully easy, to make an infinite loop. That is an infinite loop that will never exit because there's nothing modifying this value. This value will always be 1, which means anything over here will just run continuously forever, locking up the Spectrum, locking up everything. So in order to mitigate this, I've put some changes in the simulator that check for. It's very difficult to actually check logically for the potential of an infinite loop, because the input here could be anything and it can be influenced by anything. So it's actually very difficult to actually go over the code and say there's an infinite loop. So what I've done instead is in the simulator, when running logic code, it will check if a particular flow is running for an unreasonable amount of time. So if it's running through, it goes through a number of ticks. If it goes on for far too long, then I'm going to just presume that something's not right. Print a warning out to the console over here, this console down here, and exit that loop. So you can actually then, you'll get a notification of where this problem occurred, and then you can go back to your game logic and look at it and say, yes, I've introduced an infinite loop here, and you can catch that before it goes out to the spectrum and causes the spectrum to just lock up. Okay, so there's two more things on my list, I think. Let me just check. Yeah, two more things on my list to cover, and they're both quite large. So I'll cover the intersection testing, tracking, sorry. So one of the things that came up, let me just find the right test file. One of the things that came up on one of the projects, or on a number of discussions on Discord, is that the system can report or track, capture when two objects intersect. So this is a particular common mechanism here of a player and a switch that you want to switch something somewhere else in the game or whatever. And it can detect that using the I'll go to here and go to, actually we can't do that one on there, I'll have to do it. Yeah, so we got this object hit. So this object hit is a trigger that will happen whenever another object intersects with this particular object, and you can find out which object was hit. So that allows you to detect when the player's hit the switch, if we go back to the room, but while the player is in contact with the switch, it will continually fire. So it would just switch and then keep repeating that process. Whatever the action that needs to happen when the switch is switched, it will keep doing it over and over and over again until you walk away. But so one way of solving that is using the object flags node that I showed earlier to turn the layer for the switch to none. So then it won't register any intersection with the switch anymore, which is fine if it's a one-way switch. If you just want the switch to switch once and then forget about it, it's done, that's fine. But if you wanted, as is quite often the case, to be able to switch from one state to another and then switch it back again later in the game, it was very difficult to do that because there was no way of determining that once you've switched off the intersection testing on the switch, there was no way of determining that you're no longer touching it. So there's various different attempts were made in logic. It tended to get a little bit convoluted. So instead I've introduced a new feature and a new trigger type, which you may have just spotted when I was over here, which is called object left. So what it'll do now is it will track when two objects intersect and an object hit trigger is fired between those two objects. It'll keep internally a list of which two objects are touching, and then each time through the update it'll check if they still are, and when they're not, i.e. when the player has moved away from the switch, it'll see that those two that were touching are no longer touching, and it'll fire an object left trigger on both of them, which allows you then, in this case you can see it's turning the switch back on again. So if we go up to here, this toggles the switch animation, sets an internal variable, and then switches the switch intersection testing off by setting all the layers to 0. And then when it leaves, it switches it back on again. So if I now show you this in the preview, you'll see as we approach the switch, it switches and toggles but doesn't continue to do it. It's not playing the sound, it's not switching anymore. It's switched off the intersection between, and then as we walk away and move away from it so it's no longer touching, that will have turned to switch back on again, and if we go back it switches it on. So it allows you to very easily detect when you were in touch and no longer are. So very useful for switches and other in-game mechanics. I think the last thing, that was intersection tracking. The last thing is a big thing, but it's not something I can really show, but I can explain the reasoning behind it. So the simulator, as you know, is intended to be a way of testing your logic mainly. It does do it makes some attempt to replicate a certain amount of what the spectrum will look like in terms of it uses masked rendering of the sprites and so on. It doesn't try to do things like color clash or anything at the moment. That's on the list of things to look into. But it's mainly for checking the game logic that everything works. Now, the way that the logic interpolation on the simulator has worked up until now, for historical reasons, is it actually interpolated the actual logic nodes themselves. Each node that you draw in a graph here had up until now another piece of code in Kwyll that would do the task of that node within the simulator, and it would run through processing them exactly as they're shown on the graph, and that was good. It worked, and the reason historically for that was because prior to a recent change, or a change maybe a couple of months ago, the code output from the logic graphs was to C, which was then compiled on the Spectrum side, and then I switched to a mode or an approach where the code is exported to a custom virtual machine language, which is executed by a virtual machine, a very simple virtual machine on the Spectrum. The reasons for that are to do with tracking memory and so on, and it's covered in another video, so I won't go into the detail on that. So that happened a little while back, but the simulator was already operating in its mode of simulating the nodes directly, because it made sense. Trying to simulate the C wouldn't make any sense at all. However, now that we have a virtual machine instruction set that I have complete control over within Kwyll that gets executed on the Spectrum, it made sense at this point to switch to doing the same thing in Kwyll. So Kwyll would run exactly the same, the simulator in Kwyll would run exactly the same virtual machine language that gets run on the Spectrum. This gives you even more assurance that what happens in the simulator is likely to be replicated when you run it on the device, because it's running exactly the same code, literally. So I can show you how this looks. So most of the Patreon users, even the serious ones, won't use this button very often. So this shows the memory breakdown over here, which I won't go into, but over here it shows you the actual code that gets exported. It's basically just data that gets compiled into your final game. But amongst this you'll have things like this. So this is the logic, this is the assembly code effectively that gets run on the virtual machine for the player. So you've got very simple opcodes that are tailored for Kwyll in particular. There's some basic math ones and so on. So this is the code that gets exported to the Spectrum and gets run on the Spectrum, and now this same code gets generated within the simulator, and there's a virtual machine implementation in the simulator that does exactly the same, within reason obviously, because it's not in C, it's not on a Z80, but it tries to emulate as much closer the exact operations that are happening on the Spectrum virtual machine on Kwyll. So this means that you no longer have any risk of something working in the simulator because it's using a particular way of interpolating the logic code, and then not working on the Spectrum because it's using a completely different way. So this it makes it a lot more reliable. Again, there's nothing much to see. It does mean that the debugger is a bit more problematic, because obviously debugging or running node by node by node is very simple to replicate in the debugger, and it's easy to track which node you're on. When you're running the VM code, this complex bytecode here, it's very difficult to determine, or it's much harder to determine which node is currently active. It does work. If I show you quickly, I've got one of my samples. It's set up, so this is the standard game, and there's a breakpoint on firing a bullet. So it does work, and it works by, without going into too much detail, it works by annotating internally. It doesn't ever get exported because it's not important on export, but internally it annotates the generated bytecodes with some information about which nodes they came from, so it has some understanding. So it's not quite as clean at the moment. I have some ideas to improve it, but it still kind of works. So this one's highlighting here that this is the node that it's currently executing, and it's also got, because of the way that the code the way that the code generated works, a particular bytecode might be related to multiple nodes. Again, I won't go into the detail, but ask me on Discord if you want any more information. So this is basically, this is the flow at the moment that's actually responding here. So it's stopped at that one, and it's actually getting data from these nodes. So, and you can single step as normal, so carry on single stepping through, and it works. So you can still use the debugger to debug your logic. If I turn off the breakpoints, I'll carry on so everything plays as normal. So there's still some work to do on the debugger, but the benefit of having Kwyll running exactly the same code as the Spectrum is very important, I think. So that was the last big thing. That took a little while to do, and again was another reason for slowing down these updates. And I think that pretty much covers everything for this one. As I say, I'm looking to get a release out, a beta release out in some form, in time for Crash Live, which is 15th, 16th of November. So keep an eye on that. And as usual, if you like what you see, don't forget to leave a like and subscribe, and even better, pop over to the Discord and find out a little bit more detail about what's going on, and maybe get involved on the Patreon and get early access to have a play yourself. See you next time.